In this video, we're going to talk through the 4A2 notes. Talking more about triangle sum properties or applying them. So yesterday, we talked about excuse me, the fact that the sum of the measures of the interior angles of a triangle was equal to 180 degrees. So now we're going to talk about how can we apply that into some different situations. So right now, I want you to pause the video and go ahead and do example 1. Find the missing angle measures in the triangle. All right, now that you've done this on your own, there's a couple ways that I can think of to do this. One is the fact that using the fact that this is a triangle, the sum of the measures of the interior angles would be equal to 180, so we'd have x plus 8x plus 90 equals 180. Now if I solve this equation, 9x plus 90 equals 180. I subtract 90 from both sides, divide by 9, I get x equals 10. Well, if x is equal to 10, then the measure of this angle, let's label this A, B, and C. The measure of angle C would equal 10 degrees, and the measure of angle A would equal 80 degrees. Now, another way you could have done this is to completely ignore this right angle. And if I'm thinking through this, because this is a right triangle, this is a right angle, I know that's 90 degrees, which means the leftover angles, their measures have to add up to be 90 degrees, because if this is 90 degrees and total they're 180, then these two together have to add to be 90. So I could have just done 8x plus x equals 90 and solved from here. And all that really does is save me that first step, and then it would be the same exact rest of the work. But this is a theorem. There's a theorem, it's called the corollary to the triangle sum theorem, and corollary to this means that we're using this to prove something else. That says if you got a right triangle, then the two angles, the two acute angles are, well, if they add up to 90, they must be complementary. So we're going to go ahead and prove this. What I want you guys to do right now is pause the video and try this proof on your own. Once you've tried the proof on your own, play the video again to check your proof. Excuse me. It might be helpful if we draw a picture. So I'm going to draw this picture. It says we have triangle ABC where angle C is a right angle, so that would be C. Here's A and here's B. So I have my statements and my reasons. And basically, I'm just going to do a proof for what we did up here. Instead of x and 8x, though, I'm going to have measure of angle B and measure of angle A. So here we are given triangle ABC is a right triangle, and angle C is a right angle. We know that if angle C is a right angle, then its measure must be equal to 90 degrees. So measure of angle C is equal to 90 degrees. So if right angle, then the measure of the angle is equal to 90 degrees. We also know from the triangle sum theorem that we did yesterday that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. That's because if we have a triangle, then the sum of the measures of the interior angles is equal to 180 degrees. And now I can substitute in that 90 degrees for measure of angle C and say that the measure of angle A plus the measure of angle B plus 90 degrees is equal to 180 degrees, and that's just using the substitution property of equality. Notice you cannot use the transitive property of equality here because we are not replacing the entire side. We are just inserting 90 for just the measure of angle C. So this is not one where you could use substitution or transitive. And now I can subtract 90 from both sides or add the opposite of 90. And when I do that, I get measure of angle A plus measure of angle B is equal to 90 degrees. And that is the addition property of equality. And now that the sum of the measures is 90 degrees, I know that they're complementary. So angle A and angle B are complementary. That's because if the sum of two angle measures equals 90, then the angles are complementary. And now we have proven this theorem. And again, you don't have to use this, but it is maybe a way that we could do a little bit shorter version of that same problem. Alright, let's get down to here. What I want you to do right now for example 2 is to pause the video and try and figure out the measure of angle BCA. So this is the angle we want. Go ahead and try that on your own right now, and once you think you figured it out, watch the video and see how I did it. Alright, so when I do this, I'm trying to find the measure of angle BCA. I already have x in the equation, so I'm going to make a y here because I don't know what that angle measure is, but I can't label it x because then that would force it to be that same angle measure there. So I'm going to use the triangle sum theorem and create an equation for this triangle. I know that y plus x plus 73 is equal to 180. But now I have two equations with two unknowns, so I can't solve for x or y yet. But when I look over here, I haven't used this information yet for angle DCB, and I see that these two angles are adjacent and supplementary, or they form a linear pair, so I know that 3x minus 9 plus y would have to be 180 as well. So I'm going to set up another equation. 3x minus 9 plus y equals 180 degrees. Now I have two equations with two unknowns, and I can solve this system of equations. There's a couple different ways that people like to solve systems. I'm looking at this, and I see that I have this expression equal to 80 and this expression equal to 80, so I'm going to substitute in and actually do y plus x plus 73 is equal to 3x minus 9 plus y. And when I solve this system, now I subtract y from both sides, I get that x plus 73 is equal to 3x minus 9. If I subtract x and add 9, I get 82 is equal to 2x. Divided by 2, I get 41 is equal to x. Well, if I find x is 41, I can substitute in here. I find that measure of angle A would be 41 degrees right here. And now if these all have to add up to be 180, well, I can do substitute 73 plus 41. Substitute in here, solve for y, and I find that y must equal 66, which means that the measure of angle BCA is equal to 66 degrees. So that is my answer, but it leads me to want to talk about a new theorem that we could use. And that theorem relates the exterior angle of a triangle to the non-adjacent interior angles. When I say non-adjacent, I mean not next to. So we talked about how this angle right here was adjacent to this angle. So these are the non-adjacent. So I'm going to go back up earlier here. This 3x minus 9, that angle measure right there, I see that right here. And this x plus 73 is this angle plus that angle. So what the theorem we're about to prove says is that the measure of the exterior angle of a triangle is equal to the sum of the measures of the non-adjacent interior angles. So let's flip to the next page and see if we can prove that. So you're given triangle ABC, and I want you to prove that the measure of angle A plus measure of angle B is equal to the measure of angle BCD, this exterior angle here. Go ahead, pause the video, and try this proof on your own right now. Now that you've tried it on your own, I will talk through how I would do this proof. Statements and reasons. So we start with a given, we have a triangle. Now, we're not given a whole lot. We're just given that this is a triangle. So I'm going to think through everything I can think of that I know about triangles. Well, so far, all we've really talked about is the sum of the measures of the interior angles of the triangle is equal to 180 degrees. But when I look in the picture, I'm going to end up wanting to prove that measure of angle BCD is equal to the sum of these two angle measures. So I know I have to introduce angle BCD somehow into the proof as well. So when I think about that, I see BCD. This angle forms a linear pair with BCA, this angle. So it might be, I could introduce it to the proof by adding these two angles together to be 180 because they're supplementary, because they form a linear pair. Which then this angle can connect to these two angles, which also happens to be in what I'm trying to prove, using that triangle sum theorem that we talked about. So those are the things I'm trying to think through. In order to do this proof, I'm going to first start with what I thought of first, which I don't have to start with this step, but it's what I thought of first, and that the sum of the measures of the interior angles of the triangle is 180 degrees. So the measure of angle A plus measure of angle B plus, I can't say measure of angle C because there's two angles whose vertex is C, so I'm going to say measure of angle BCA is equal to 180 degrees. And this is because if I have a triangle, then the sum of the measures of the interior angles is equal to 180 degrees. Well, we also said that because these two angles are a linear pair, they must be supplementary. So angle BCA and angle BCD, and I'm going to make sure I use the same order of the letters so that I don't have to use a reflexive property at any point, are supplementary. And this is because, what did we say? Oh, if linear pair, then supplementary. And then we can say that the measure of angle BCA plus measure of angle BCD is equal to 180 degrees, and that's because if two angles are supplementary, then the sum of the angle measures is equal to 180 degrees. Just gotta squeeze that in. Alright, so now, just like I did on the front page, I'm going to set these equal. I know that this guy is equal to 180 degrees, and this guy is equal to 180 degrees. So I can use the substitution property of equality or the transitive property of equality, doesn't matter, to say that step 5, measure of angle A plus measure of angle B is equal to, just kidding, plus measure of angle BCA, that's equal to the measure of angle BCA plus measure of angle BCD. And I am so very close to being done. And we said this was the substitution property of equality or the transitive property of equality, either one would work. All I have to do is get rid of that measure of angle BCA, and the reason I can do that is measure of angle BCA is on both sides of the equation, so if I subtract that, or add the opposite of that, I will have my final proof, or my final statement, rather. So that was the addition property of equality. So what we can say is that the measure of the exterior angle, this guy right here, is equal to, so I'll underline that, is equal to the sum of the measures of the non-adjacent interior angles. And that might make some problems easier to do in the future. Alright, sketching down here, there's one more theorem that we can prove using this idea of the triangle sum theorem. And it's called the third angles theorem. And what it says is in these two triangles, if angle A and angle D are congruent, and angle B and angle E are congruent, what do you think you can conclude? Well, if you said that angle C and F must also be congruent, you would be correct. Angle C must be congruent to angle F. So that's what we're trying to prove. So I'll have my statements and my reasons. Angle A is congruent to angle D, angle B is congruent to angle E. I know at the very end I want to prove C congruent to F. If we're dealing with the angle measures in a triangle, we have a few things that we've learned so far. We have the measure of the exterior angles is equal to the sum of the non-adjacent interior angle measures, but we don't have exterior angles, so that's not going to be super helpful. If we flip to the front, we have the fact that if we have a right triangle, the two acute angles must be complementary, but we don't have right triangles here, so neither of those will help. So really the only thing we have about triangles then is that the sum of the measures of the interior angles must be 180 degrees, which that might get me to where I want to go because it introduces angles C and F into the proof, and I need that in my conclusion. So this is my given. My next step will be that the measure of angle A plus the measure of angle D, measure of angle plus measure of angle B, plus the measure of angle C equals 180 degrees. And also that the measure of angle E, well, A will correspond to D. Let's do D first. Measure of angle D plus measure of angle E plus measure of angle F equals 180 degrees. Now, I don't know if I need both of these statements. I'm going to put them here right now and see if we need both of them as we do this proof. So this was because if I have a triangle, then the sum of the measures of the measures of the interior angles is equal to 180 degrees. So from there, I know that A and D are congruent and B and E are congruent. And if they're congruent, they must be equal in measure. And so I'm going to use that so that I can substitute these in. So measure of angle A must be equal to the measure of angle D, and measure of angle B must be equal to the measure of angle E. And that's because if the triangles are congruent, then they are equal in measure. And now what I can do is I can substitute these in. So what I'm going to do is I'm going to take measure of angle A equals D. I'm going to substitute that in here. And measure of angle B equals E. Substitute that in there. So step 4, I'm going to take that equation that I used to have and I'll say measure of angle A plus measure of angle B plus measure of angle F equals 180 degrees. That was using the substitution property of equality. Well, what I have to do now is I have this guy equal to 180 degrees, this guy equals 180 degrees, which means I can set these two expressions equal to each other. So step 5 would be that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to the measure of angle A plus the measure of angle B plus the measure of angle F. And for this one, you could either call that the substitution property of equality, or you could call that the transitive property of equality. And now we see that I have measure of angle A on both sides and B on both sides. So if I add the opposite of A and the opposite of B, I will get measure of angle C equals measure of angle F. And that's using the addition property of equality, which means that if they are equal in measure, these angles must be congruent, which is exactly what I was trying to prove. So if angles equal in measure, then angles congruent. And I've proven the third angles theorem. So these angles must also be congruent. Going back up here, I could have done step 4 first and set these expressions equal to each other and then substituted in A for D and B for E. It doesn't matter which order I did that. This is just one option. All right, so what the third angles theorem says in words is that if two angles in one triangle are congruent to two angles in another triangle, then the third pair of angles are also congruent. And we'll put these on our proof sheet tomorrow.